last but not least, we have Eric Milgrant with the Sanibel Captiva Conservation Foundation. And the title of his presentation is The Cumulative Effects of Regulated Discharges on Seagrass Density and Community Composition around Sanibel.
Good afternoon. I need to thank some co-authors here. It's a team of people. We're very lucky to work with also our federal agency, the U.S. Fish and Wildlife Service, and I want to acknowledge Joyce Palmer, who works with the Garden National Wildlife Refuge, as well as some of my colleagues at the lab. So the questions that we're posing with the talk today are mainly looking at high flow periods and trying to understand the lower estuary what the responses of seagrass communities are. So we're looking at areas around the Sanibel Causeway. And the second question is whether there's a cumulative impact. So if you have multiple years of high discharges, is that changing the composition and some of the community metrics that we've been measuring? And then finally, I wanted to address the 2013 discharges. They were more prolonged than previous, and wanted, how did those affect seagrass communities? So as a quick summary, I want to thank Chris and Dave for talking about why seagrass are important and why they're a good indicator. And also wanted to put up this slide. Chris was able to talk about the aerial seagrass estimates from lower Charlotte Harbor, but they were summarized in a couple of papers, one by Catherine Corbett as part of the effort for CHNEP and Florida scientists. And I just wanted to show you that she found 10,000 hectares in Mount Sound and 1,700 hectares of seagrass in St. Croix Bay. That's included, that's continuous and patchy together. We were talking about acres before, now we're talking about hectares, so you know you can get out your smartphone and plug some numbers in. In 2011, the FWC, Florida Wildlife Research Institute, put out a statewide assessment of seagrass based on aerial estimates, doing a regional sort of synthesis. What they noticed in their trend analysis is that seagrass aerial extent was increasing in Mount Sound and St. Croix Bay. And this was based on aerials through 2008. Thanks for clarifying that earlier, Chris. And however, there were declines in water quality in certain areas. And this is perhaps an early indicator that we'll see some responses to lower light levels and lower salinities of seagrass, but also greater crop scarring. So I think the recommendations we've all kind of been living with and following in order to protect the resource, not lose more of the resources, to focus on our water quality, try and examine some no combustion water zones. So what we started seeing the effects of the high discharge events all the way back in 2005. We started studying some leaf emergence rates in Glacia. It's a simple technique where you mark the leaf, you measure the growth over time, and it's a measurement of the ground production in Glacia. And without going into a lot of details, because it's in a manuscript now that's in review, I hope it will come out soon. What we found is that sites within 5 kilometers of Shell Point, which is essentially river mile 0 for the Sahatchee, we found lower leaf emergence rates when compared to sites farther away. And we attributed that to salinity. The light levels were probably also confounded in with the salinity because lower salinities bring darker water and can create light limitation. So during the last 6 years, since 2007, we've noticed every year, we have wet season and dry season. And the wet season, you can see these are flows from S79. They show up in this graph. The targets to minimize harm in the Caloosahatchee have been established through a lot of science and are in a lot of reports, most notably the Northern Estuaries Restoration Recovery Plan are in red. You can see that we've had a lot of years where we're in exceedance of those high discharges. So that caused us to want to focus a little bit more on the lower estuary effects. For our own salinity data that go back to the beginning of 2008, the red is the daily mean, and then the blue and the green are max and min at shell point, which is essentially river mile zero for the Caloosahatchee. You can see that seasonal signal again during the last 2012, 2013, and the beginning of 2014. It seems like the last 3 years we've had lower salinities in the lower estuary progressively. So I asked Mindy to prepare some of her San Carlos Bay transect data for me. Mindy is in charge of the Charlotte Harbor Aquatic Preserve transect monitoring. And you can see, especially these last 3 years, an increase in summer discharges. And that's, as Dr. Marsden alluded to earlier, some from the watershed, some from the lake. This year, in 2013, there's actually a greater proportion from the lake, but it can be as much as half or as little as a third. But you can see, and I tried to align her data with that's why it's offset. I tried to align the years of her data with the flow data. But I want you to just note these last 3 years, 11, 12, and 13, and here is 11 and 12. We're sort of seeing a decline in sheet density. So in 2009, we were conducting some seagrass monitoring within the Darling Refuge. So those are the blue points. Part of the bay is where our lab is located, and then various parts of the Darling National Wildlife Refuge. And we, during the high flow periods, there were some times where the salinities within the refuge weren't changing a lot. They were changing a small amount. So we decided to do a targeted study more in San Carlos Bay, where the effects of the high discharges may be apparent if there weren't. So we added six locations. Some of these are historic sites that had already been chosen. We had previous data on, and then others were new sites. So overall, one of the other reasons why we wanted to look at this is that if you looked at the blue, this is the next table is a summary of the blue sites within the refuge. For Haliduli, we noticed decreasing trends, although our square value is not very strong. There were significant decreasing trends in Tarpon Bay, in the outer estuary sites, and in the inner estuary sites. While at the same time, there was an increase in macroalgal percent cover. So the Haliduli numbers are actually sheet densities, and the macroalgae is percent cover. Just to illustrate this is Haliduli in the Tarpon Bay sites, and you can see the colors. Each color is a different year. Actually, this is all 3 species. You can see the decrease in Haliduli. Valencia is more or less stable, and Serengonium more or less stable. But then there's been a dramatic increase since 2010 in macro. So in order to go about doing this, as I mentioned before, we added these red locations, and we did a modified BACI, which is kind of a before-after control study design. And we went out before 30 consecutive days of 2,500 CFS. It was kind of right at the beginning. We went out in the middle of the wet season after August, October, and again in December. And then this year, 2013, past year, the discharges started much earlier. We had a very wet year in Florida, and we had a lot more water coming through S79. We started actually in June. We had a midpoint correction at the end of August, and then did our post-assessment in December. And in 2013, we also added sites that are considered more control. We thought we would get some control, or not control is the wrong word, but less affected by high discharges down here near Tarpon Bay. But since we had increasing discharges successfully in the past 3 years, we added a site way up here in Tamariki that presumably is mostly out of the influence of the Coxhatchee, but maybe some local runoff. So we were surprised in the first year. We saw an immediate effect of a decrease in sheet density for Thalassia. In successive years, if you just look at, these are the sites that have Thalassia. Some of our sites don't have any Thalassia. You'll see from the beginning of the wet, well, before really the high discharge start, to the middle to the end, there's a decline in sheet densities. And it progresses through the wet season. At the control side in 2013, you do see some decline. That's this box here. You see some decline, but proportionally it's not as great as some of these others that we see. And then the one other thing I want you to look at in this graph, you can see it if you stare at it for a long time, which is what we've been doing. But you can see during the 3 years there's a decrease in sheet densities. And we also looked at the post, and there's a decrease. And that's not going on there, but it is here. In most sites, we're seeing potentially a cumulative effect. So Haladuli may be a little bit more resilient to high flows, which you would expect because it's it's tolerant of lower salinities. That's has been reported for Shell Harbor as well. You can see an initial decrease in sheet densities, and then what seems like to be a stabilization or some kind of a, for example, here. The first year we have an initial decline and then stabilization. At Site 9, I think there's something going on there where the mixing with clear Gulf water is leading to a combination of higher light, and the Haladuli is very happy at that particular site. And again, if you look at the control sites, which are presumably, there's a lot of assumptions here, but they're out of the influence largely of these frequent changes in salinity and large magnitude changes in salinity. You can see some decline related to day length or solar angle, but it's proportionally a lot less than what we're seeing at the sites in St. Carlos Bay. So we did some statistics. They're pretty straightforward at this point. We're doing GLM and ANOVAs. For Thalassia and Haladuli, pre, mid, and post, we're seeing significant decreases in sheet density. For the back analysis, which would only be 2013, we used a technique that was published by McCabe, and we noticed that Thalassia had significantly decreased density. So in that analysis, it includes the control site. So it's a slightly different statistical assumptions associated with it. And then for the cumulative effects, for Haladuli, the pre-sampling period has been, in year 1, significantly higher than in both year 2 and year 3. And for Thalassia, it was the post-sampling that was significantly lower in year 1, or in year 2 and 3 versus year 1. So I guess in summary, we want to emphasize the importance of some of the in-water work and the transect work that's being done, and that we shouldn't always rely on aerial photography, although it really gives us a snapshot of regional sort of things that are going on. It's very useful for a lot of things. But I did want to show you one hydroacoustic monitoring that we conducted in Pine Island Sound, and it's really hard to see, but this is all inside of this green area. It's considered continuous seagrass. We drug our hydroacoustic sampling device over the edge, and it was red, so the actual edge is over here. So your area calculation is probably going to be affected by that. And then also, once you get into the middle of the bed, there was large areas with no vegetation. And I'm sure Matt and Peter could talk in more detail about the importance of parameter and combining some aerial imagery with any water work, whether it's hydroacoustic monitoring or other things. So it seems like for the lower Caloosahatchee, there's an initial rapid decline, and it was very apparent this summer when we had a lot of leaves, seagrass leaves, wash up and dry on the causeway islands. So that initialized earlier this year than previous years. I think there are a lot of reasons why you could get a decline in shoot density through the wet season, including self-shading, including day length, sun angle, and so on and so forth. But I think what's really going on is that the plants are responding to the low salinities, shedding their leaves and losing shoots. And it's happening in a greater proportionally in the lower Caloosahatchee versus the control sites. So that's the second point, that there is a relatively small reduction in median shoot losses related to sun angle, daylight, self-shading, etc. The other thing that's a little bit, one of the things that we're trying to study more and understand more is macroalgae, the distribution, species composition, nutrient uptake, what the common species are. We have seen a significant increase in macroalgae in St. Carlos Bay and in the refuge. So we're interested in looking at that a little more. I'm going to go fairly rapidly. Rick made a lot of
I got to get her separated.
This was in July 2013 that Rick just passed. We had extremely early onset of the wet season. That was because of the regulated discharges from the rest of the state of Florida. We didn't have to feel the effects. If you look at it compared to other years, it was pretty high up there, second or third in the last 14 or so years. And then Rick showed this already. If you just look at wet season discharge, 2013 was higher than anything since 2007. Salinities in the refuge were quite low. They were below 20 at times. And if you sustain that for a long period, it's well understood that Valencia is not prescribed. If you look at salinities just in Tarpon Bay, these are the different colors of the different years. 2013 is the purple year, and the scale here is 15 to 25. So we have a long period of low salinity in Tarpon Bay. We need to continue our transect work and data collection and aerial photography to sort of understand these climatological changes, and hopefully dampen some of the high discharges and get support for big projects that will help store water and convey water south. So with that, stay on and answer you now.
Okay, you mentioned microalgae. Well, what is that microalgae? What is that filamentous? Talking macrophytes. Give us a little more about that.
Sure. I mean, the most common thing is gracilaria, which it's something you can see. It can be filamentous, but most of the time it's a regular feature of seagrass communities to have drifting macroalgae. But we've been seeing higher percent cover. We've been quantifying now biomass so that we can have a better understanding of it. And then also the common species, because there is a large diversity of different species responding to different things. So we're using that data collection and combining it with the physical data and the nutrient data that we've been collecting to better track that. I think we know lot more than we did 5 years ago. But we're seeing more stranded on the beach. We're seeing it more in our data. So it's something that we're trying to keep track of.
Testing. Eric, you mentioned 2013 stands out, because with respect to recent history, because it was actually an average year in rainfall for as far as Florida compared to the previous years where it's been a drought. Assuming that we return to a more normal hydrologic cycle and we continue years like 2013 in the near future, what types of anticipated results in seagrass metrics that you're covering, perhaps other seagrass metrics, would you in light of no changes in the regulation of discharges with this action, would you expect in the near future if we continue to have years like we had last year?
Well, I think, you'll have shifts in composition towards more salinity tolerant species, either macroalgae or algae, but it may have been an average rainfall year for Lee County and Sarasota County, but it was a record rainfall year for other counties in the state, and that's why we have so much discharge. But based on the last 3 years, we've seen declines in chute density. Mindy's seen it. We've seen it in our data. It'd be really interesting to look at the 2014 aerials and see if any of the extent has changed. But I think extent doesn't necessarily tell you the functional response of the community, and that's why that water work is important. But I suspect we're going to have a lot more macroalgae and a lot less seagrass in the next decade.
Thank you so much, Eric.